So this talk is called Scaling xUnit Test Runners. I told that title to another speaker yesterday, and he was like, "What does that even mean?" And I said, "I don't know. We're going to find out." So before I start, could I just get a show of hands? Like, who has like a tester title? Okay, most of the room. And anybody have a dev title? And what about like ops or infosec? Oh, cool. One. That's the same as yesterday. Okay. It's just always interesting to know. One of the reasons I ask is just because I think a lot of the tools that I talk about are very familiar to ops people and infosec people, but not so much to developers and not so much to testers. So it's just sort of interesting as the DevOps movement has grown to kind of help cross-pollinate and share these ideas. So what is an xUnit runner? An xUnit runner is basically just a tool that finds all your tests and runs them. The term comes from Kent Beck, who developed the first xUnit runner for Smalltalk back in the 80s. Interestingly, the xUnit runner for Smalltalk was based on a book which no one today seems to be able to find, a very old programming book, which Kent Beck found when he was developing the Smalltalk. And this book described how you would punch a tape. Back in the days when computers used punch tape, you would punch a tape with the output you expected from your program, and then you would run your program over and over again until you got another tape out of your program that you could hold up and they were the same. You could hold up to the light and look through it and see they were the same. So what's really interesting to me is that from what I've read, when Kent talked to older programmers about this, even though unit testing in the 80s wasn't really a thing, all of the great microcomputer programs were developed, as far as I can tell, without really any testing. So all that great stuff for the Macintosh and the PC in the 80s, no testing. But what's interesting is when Kent talked to the mainframe developers, they all said, "Well, yeah, of course we make a tape, for a test, and then we check that the output matches. I mean, how else would you do it?" So xUnit runners are this interesting tool that's sort of been lost and found again over the ages in computing. So I said I'd talk about a couple of things. One of them was the implementation of xUnit runners. So here's a simple xUnit runner that I implemented for one of my projects. It isn't much code, but this actually reflects lots and lots of hours of going over the source of other test runners, mostly for my job, just to understand how the tools work. And this here actually is the core functionality of any xUnit runner. You can see we find the tests in the test directory, pass the test through to parallel, which is like Zargs, which runs the tests. And then there's about half of the runner is consumed with just getting you the right output. So this is basically it. But there's no standard for xUnit runners as far as I can tell, other than that maybe you should print some dots. There's lots of different output standards, but there's certainly no chosen one. It's actually an area of a lot of opportunity for those of you who have who like to make tools. There's a lot of standardization and improvement that could happen in the xUnit runner world. One nice thing about my runner here is that it's concurrent using parallel, so it runs all the tests at once rather than one at a time. Node.js is the only current platform I know that defaults to a concurrent test runner. So in Node.js, typically when you run your unit tests, they'll all run at once, and it's really, really fast. And you find out instantly if you have any kind of test dependencies or test conflicts because everything's running at once. This is also a real opportunity for every language and platform out there to build a concurrent unit test runner. This is something that we were all talking about, I feel like 3 or 4 years ago. Everybody was working on it, and then it just sort of got lost. And what I see people doing today is making the test concurrent through Jenkins, so grouping tests and breaking them up, and that's good. But there's, I think, obviously concurrent runner where every single test is concurrent would be faster, and then you could still shard it with Jenkins. So here's another test runner implementation to take a look at. This is the PHP unit test runner, just a little chunk of the code. You can see it's doing pretty much the same thing as my runner. Find the tests, run the tests, aggregate the return status of each test so it can be returned to the user when the run is over. And if you look at the source of the xUnit runners for Ruby or Java, you'll find the same patterns. So that's pretty much it for test runner architecture. It's pretty simple at the core, and all of the fancy features, if there are any, those are all sort of up to the author. There's not really any standard that says, a test runner needs to output JUnit and JSON, and actually you find they vary really widely. Some of them just output tap, some of them just do plain text, some of them do all kinds of amazing sophisticated stuff. But again, there's strangely, there's no standard. So I think the most important topic I'm going to talk about is just how to get the output you want from the runner. And it mostly comes down to regular expressions. Regular expressions are an incredibly powerful tool for testers because regular expressions are how you transform text. For instance, if you have if you have a whole bunch of logs and you want to transform them into some kind of time series, you can use a regular expression to do that. Regular expressions are also great for finding things, finding patterns in logs, finding patterns in failures, automatically finding strange errors way up the stack before this test failed. I accidentally read the O'Reilly regular expressions book first when I was learning to code, and it was one of the best things that I could have done for my career, because actually most programmers are not that great at regular expressions, because to build a web application and a shopping cart and your typical stack stuff, you don't actually need regular expressions very much. But once you're doing investigation, and this is kind of the ops part, then regular expressions become really useful. And also, when you have a tool that has ugly output and you want to transform it into pretty output, regular expressions are how you do that. So this is it going to play? There we go. I love this. So these are differential interlocking gears. I found from Google is the name of this, or phased interlocking gears. So the gear in the center goes backwards and forwards, but the driver only goes in one direction. This is so basically the effort from the drive shaft is translated or redirected, and other kind of work is done. So this is a great metaphor for the way that I relate to test runner output. The test runner is going to give me the output, but then I can make it do whatever I want using regular expressions. Obviously, I had a little bit of fun finding these, but I think this is a really important point about. There's a principle called string transformations in information theory, which says that if you have information in one form, you can transform that information into any other form. So a lot of times I've worked with dev teams and I've heard people say things, well, I've heard people say things like as ridiculous as, well, we can't test that system because it's a black box. Just like, really? But that attitude exists a lot, I think, because people don't understand that there is this whole language of regular expressions that you can use to get whatever output you want, rather than being stuck with whatever output the tool gives you. If you have output in XML, you can have it in plain text, you can have it as an image, you can have it as a PagerDuty notification. You can have it as a voice message on your phone. It's just a matter of how much work do you want to do and what APIs do you want to subscribe to today. So I think that that's really important message for somebody like me to put out there, because I talk a lot about, I'm building all this cool stuff and my team is doing all this cool stuff. It's really important to realize that the way that I'm doing that is just starting with like, what do I have and what APIs and what regular expressions do I need to turn it into what I need. All right. This is a puppet. The nature of a puppet is that it doesn't matter whose hand is inside the puppet. The puppet, it determines that you're watching the Swedish chef, right? Not the hand. It wouldn't make sense if the hand determined what you were watching. So the puppet is a wrapper for hands in general. Anyone's hand, in theory, can go in here and you'll get the Swedish chef out. That's a lot of the principle that I think applies when building nice output for your team. It shouldn't matter what goes in. You should be able to control what comes out. So there's a principle called inversion of control in computer science, which basically says for any interface, it shouldn't matter what's underneath the interface. So if you have ugly output from your test system, which is the hand, all you need to do is transform it into a palatable format, which is the puppet. So I'm not going to go into these in detail. I think I talked about these a lot yesterday in my talk. So, but these are some tools to Google if you're not, if you're not familiar with tools to transform these formats. XML Starlet is old and uses XSLT, but that's XML for you. It's the best way I've found to work with XML. JQ is new and really magical. It lets you work with JSON the way you work with plain text using awk or sed on the command line. And then awk or Perl are amazing for transforming any kind of text output, including tap. So if you want, let's say your runner only outputs tap and you want JUnit, you could use Perl or awk to transform your tap output into JUnit.xml. So let's talk about test instrumentation, which I think is something that is kind of new. How many people are using or are familiar with a tool like Grafana or Graphite, some kind of ROD tool that builds graphs? Okay, so not too many. So this is something that you might want to ask your ops team about. Often your ops team is already using a graphing tool. And you can either use their instance or they can set up another instance for you to play with. So I'm also going to talk about network analysis and profiling, but let's go into graphs. So here's a graph that I have at Teachers Pay Teachers where I work right now. And I think that you cannot, you can't actually read it, but that's okay. Let me just talk through this. So I made all of these graphs using Grafana. This is just various data from our system that's sent to the graphing system by using regular expressions to transform various logs into time series. By which I mean, For example, this graph represents the number of methods over 20 lines that are in our controllers. So you can see here, like we did a little refactor and we got rid of some long methods. So I basically just have a grep inside a Jenkins job that counts how many long methods were reported by PHPMD, which is a static analysis tool. And I grep for reports in the models directory. I count them, and then I send them to Graphite, and that's how this graph is created. And then these vertical lines represent every time somebody introduced a new long method in a pull request. So this is this really interesting granular view into how just the controllers are being developed. And it's all hand-built, basically using these techniques. And this is more directly related to xUnit runners. This is test coverage on our models directory. It's a little funky thing going on here with the graph, but basically, you can see like we just sort of incrementally are increasing our coverage on models, and that's again done by running the PHP unit test coverage, getting a test coverage report, processing it with grep, running it through a couple of regular expressions, and arriving again at a number and a timestamp that I can send to Graphite. So this is how that's done. I dropped a statement pretty much like this one in the post-build tasks for the coding standard job and the test coverage jobs. So let me talk through this a little bit because I think this is there's some interesting tools here. So the NC here is the netcat command, which may or may not be familiar, but netcat is this incredibly powerful command line tool for sending or receiving just about anything over the network. And then Graphite, like I said, is the graphing tool. One of the neat things about Graphite is, so I'm sending a metric called my.metric. Graphite will, so that, Graphite metrics are like a file system, but they're delimited by dots instead of slashes. The cool thing about Graphite and about RRD tools in general is that they'll create the metric for you if it's not already there. So there's no configuration on the server side. If you want to start sending a metric called, model.coverage, you just start sending that. And Graphite will show it to you, and then you can make a graph. And the date plus %s part there, that's just creating a Unix timestamp for now on the command line. The nice thing about using the date command to create your timestamps is that if you have log data with timestamps going back into the past, you can just feed those timestamps into the date command. It'll create Unix timestamps for the right time, and you can send those to your graphing tool. So all you need to do to make this work for you, if you had Graphite running, is change the metric name, replace the number 5 with a variable that contains the metric you want to graph, and obviously change the Graphite host. So, and you'll find this throughout all of my Jenkins jobs. I just send, anytime I think of a metric that might be useful, I just drop one of these lines in there and send it. And I have, I have a couple of thousand metrics that go in on every build. I save granular timing information for each test, coverage information for each test. I don't use it very much yet, but it's there when I need it. And it makes it easy for me to answer questions like, what are our top 10 slowest tests? That's a great question to ask when you're instrumenting your runner. Because often what you'll find is something like this. So this is a graph from Etsy where I discovered that 20% of the tests took about 80% of the runtime. And by eliminating or fixing these tests, we were able to speed up our test suite by something like 30%. So profiling your test can start out pretty simple. This chart was created in Google Sheets. I just pasted in data that again, I had extracted the data from the etc test suite logs using grep and some regular expressions and some command line trickery. So you can use any profiling tool that's available in your stack to examine your tests. You can get really sophisticated, and this is a place where it's fun to talk to ops or to talk to a developer who's responsible for performance. There's some, for whatever your stack is, there's some really interesting tools that'll let you see all the system calls, where your tests are using memory, what network calls they're making. But you can start out really simple with, just by pasting something into Google Sheets, and you can have a really big impact. So another thing I promised to talk about is how do you add functionality to a test runner. So this is more of a demonstration of a principle than something that you'll necessarily be able to action, but I want to make a point here. So a test runner at the end of the day is just an API, like any other API. If it doesn't do what you want, you can hack it up to make it do what you want. Usually you can work by wrapping it, like I said, by just putting a cute facade on the front that does what you want, but sometimes you can't. If what you want is actual functionality and not just display, then you have to get into the code. As long as you're okay with total hacks, because in the testing world, things are rarely pretty in terms of change. We typically don't have workflows for our test runners or standards around how we're modifying our tools. You just sort of have to get in there and get dirty and do it. So here's an example of adding some functionality to the Codeception runner, which is a PHP unit test framework. And the result I wanted was to be able to highlight any DOM element with a little green dot, so that people could look at videos of my test runs and actually have an idea of what's going on. Because typically, if you watch a Selenium test video, it's just sort of like things flashing by really quick. And if you're familiar with the test, it's great, you can tell what happened. But for a project manager or a stakeholder who's not familiar with the tests, they're just like, what did it do? It's like, okay, cool, I can see all the pages are there, but like, what did you actually do? So by reading the documentation and the code, I know that Codeception has this top level object called acceptance tester. And at runtime, acceptance tester contains all the test runner's methods. So it's just a matter of injecting my new method into the runner. So what would it look like to actually do this? For me, it would look like this. So this is not beautiful or elegant code. This is kind of ugly. This is a jQuery script that's nested inside a PHP method. And the PHP method is then placed inside the main object for Codeception. So Codeception makes it easy to do this, but that's really just a convenience. There are many times where you just have the source of the runner and you just read through the code and figure out where your method belongs and put it there. So in production, for tools that you're using to make money with, it really sucks when you fork an open source project, because then you're stuck with the maintenance of that project forever. And if you depend on it and you make money off it, that can be really bad. There's a thing where forked projects tend to just sort of accumulate developers and become this burden. But for test runners, it's a different deal. I would claim that for all development tools that are behind the firewall, so to speak, that are not client-facing, it's a different deal. The principles, all of the safety principles that apply to the production stack do not apply in test. In test, you just need to get it done and get the output that your team needs. Also, in terms of forking a runner, you're much more likely to be able to either contribute that change back someday, because test runners, unlike something like Express for Node or like Nginx, right? Those are changing constantly because people are constantly finding security flaws. There are a lot of business drivers. There are a lot of executives saying like, "Hey, we need to do X," and then there's developers making changes. And test runners aren't like that. Test runners tend to change really slowly. You may have noticed. And they tend to be very conservative in where they make breaking changes, exactly because this is how it works. In talking and interviewing to a lot of test professionals over the years, this is just how it works. You hack up your internal systems. Everybody's build is different. Everybody's internal needs are different. Everybody's team is made of different people. And there's no external money pressure, right, on these tools. You just need to make them clear. So does anybody feel like this is like really dirty? Like this is like sort of crappy? Yeah, okay. Yeah, it is. But again, in test, that's the right way. All right, so here's something fun. I said I would show you how to get emoji results from your test runner. This example is a little goofy, but it makes the point that you really can show whatever message you want to your team. So what I'm doing here is, so first of all, this is, I'm echoing the failure in here, but in reality, you would pipe the output from your test runner. And then I'm simply grepping for failure in all caps, assuming that the test runner prints that. In reality, what you need to do is you need to go and look carefully at the output from your runner. It's almost like, or it is like building an object repository when you're doing functional testing. You just need to make a catalog of messages that your runner prints out. Often what I'll do is download the source code of my test runner from GitHub, and I'll grep through for the warning messages that I know are there. So if I know that it says, failure in all caps when the test failed, I'll grep for that in the source code, and that will lead me to the file that has all of the messages in it. And then I'll just sit there and look at all the messages and decide what I want to transform them into. To show, just so you understand how this works, let me just show quickly the Stack Overflow page. So basically, in order to get the Unicode emoji, you just need to, you can either look it up in a table, or you can use this neat trick and, oh, I'm sorry, it's not on the right. Let's try that again. Cursor up there. Fun. There we go. So that's how you look up all these different Unicode characters. And this is actually, who uses Slack? About Oh, cool. How about IRC? Okay. So if your team's on chat, actually outputting emojis for various states of the build system can be really useful. People respond to emojis. Obviously people respond to emojis really well, and emojis carry a lot of they can carry a lot of nuance that often is missing from typical test runner output. So another thing I've done in the past that I don't have a screenshot of, but is I had a dashboard at Etsy for a long time that took all of the output from all of the various test suites, and I think we had 7 or 8 of them at the time. And we had the typical extreme feedback board with the, one line for each test, and it's like blue and red, and it's yellow, and like there's all these different test names, and it was very hard to interpret what it meant unless you were very close to the test, which not everybody is. So what I eventually did is I boiled the Jenkins extreme feedback plugin. I boiled that down to a screen that simply was green and said OK. And then if the test failed, it turned red and it said failure. And this was actually incredibly popular and was up on the wall at Etsy for a really long time because it actually it made the test results actionable, or it made the test results feel actionable, so that people felt comfortable saying, okay, well the tests are failing, I should do something, rather than the default output, which is just sort of overwhelming. I think that that's a theme in just generally in test technology, is that a lot of tools, xUnit runners, Jenkins, a lot of tools come in what I call alienate your team mode, where they just are, by default, they spam all of this information, they give you way too much detail, they often hide the detail you actually want, and it's really, I would say it's on us as test professionals to be able to tame and tune that output down to whatever the team is going to be comfortable responding to. And the reason I emphasize this example is that it's kind of ridiculous, but this is the kind of stuff that I wind up doing for my teams in order to get them feedback that they're comfortable with. Often in user experience research, when we actually talk to people, what they wind up telling us they want is really counterintuitive. I never in my life would have expected that an intelligent, engaged developer who is capable of writing a compiler, who can fix these crazy caching problems in production, would come to me and say, I don't want to read that test runner output. It drives me crazy. Like, it confuses me, it freaks me out, it overwhelms me. I never would have imagined this, but in talking to people, this is what I found. So there's a principle here, which is that you need to hack up your test runner. Maybe that's because there isn't a great standard. There's certainly an opportunity to build better standards into our runners, to create some kind of output standard. I think JSON is okay. XML is terrible. Tap is like, what is that? And if you look at the JSON output from runners, that's not standardized. So there's for those of you who are interested in open source and community building, there's some real opportunity here to just make things more comprehensible in the industry. I mean, I think it's notable that all CI servers come with these very sophisticated tools for parsing any kind of test output, and that's how we are able to relate to it, is through the CI server. I think it would be a real benefit to just be able to relate to the runner and not need to put a web service in front of it just to tell you what happened. So, and there's a overall principle here that I think doesn't get emphasized enough, which is that dirty, direct, hacked up code, that's okay in test. Ian Dees, who's a brilliant engineer who wrote the first Cucumber driver for iOS, Ian once said that testing is always going to be a big pile of hacks. And he said that in describing his own pioneering test runner for iOS. So it's true. Testing is always going to be a big pile of hacks. You need to do things in test that you would never do in prod. So in production, there's all kinds of risk to reward trade-offs. My favorite example is a shopping cart. I've worked on many websites where it was really hard to tell how the shopping cart worked. But if you don't know how your shopping cart works, it's still making you money. And so there's a balance there, right? You could refactor it, you could rip it out, you could rewrite it, but you might lose money, and that would be bad. And so it's better to make the trade-off of having some code that everyone hates, but hey, we all have a job to come to, and we all get a paycheck that we can then spend at the bar complaining about how much we hate the shopping cart code. And that's the cycle of life. But in test, there's no money, right? The revenue in test is comprehension, right? It's the team's comprehension of what is right or wrong with this particular test run. Beyond that, tests have no value. So clear, comprehensible test code is really, it's the only value that the tests have. And often, direct, hackish, unelegant code is way easier to read. I don't know if any of you have noticed this, but if you look at my code, everything's procedural. There's hardly any logic in any of my code. It's like, do this, do this, do this, print this, send this, done. It's not pretty. I have a lot of duplicated code in my scripts, but it's really easy to read my scripts. And because I have duplicated code, now here's something you'd never say at a development conference, but because I have duplicated code in my scripts, I don't have dependency issues. You can take, now, I mean, keep in mind all of my scripts are bash scripts, which are like 20 lines long, like the code, there are slightly larger versions of the code that I showed there. This is not a philosophy that you could use to build a framework. The framework would collapse under its own weight. But if what you're doing is, again, building little tools that help people to move forward, it's actually a real benefit to not have any dependencies. It's actually a real benefit to have everything in the script, so the developer who's not familiar with what's going on, which is any developer, right, can just pop it open, read through it, and have a shot at understanding what's going on. Because as we all know, when developers are faced with funky tests and complex code behind it, they just move on, right? I mean, that's the reality. You can always skip the tests. So you can always skip the test, you can always ship. It's an unfortunate fact. So a cart that no one understands still makes money, but a test that no one understands is worse than useless. It's actually a detriment. It creates false confidence, and it creates confusion. So this is a principle that I really take to heart. You have to do whatever it takes and be as direct as possible to get the output you want from your tools and get the output you need in front of your team. Eric Kastner wrote Deployinator and wrote StatsD, and is one of the most brilliant engineers I've ever met. And if you look at Eric's code, it's very procedural. It's do this, do this, do this. It's not pretty. It's not necessarily super elegant, but it works. And it is really easy to read. If you look at the original version of StatsD, it's like a couple hundred lines of JavaScript. And you can certainly look at it and think and find lots of elegant ways to improve it and frameworkify it and all of that. But the reality is that that the tools that tend to actually be effective are written this way. So that was the talk. Are there questions? Yep.
I have a question about maintainability of those scripts. So I have a lot of them, and let's say one of the script depends on, or maybe a lot of scripts depend on the runner. Once the runner is changed, your scripts are not working anymore. So how much time does it take to update them all?
So test runner output doesn't really change very much in my experience. Again, because...
That was just an example.
Huh? Oh, sorry, then I'm not sure I quite understand the question.
I mean, in any case, if something changes on what your scripts rely, you have to update them. How often do you have to do this maintenance?
In my experience, for the kinds of things I'm talking about, almost never. Again, because we're not talking about something like Nginx or Memcache where there are people constantly anything that's in production, right? There's constantly security patches being submitted. And then there's constantly feature improvements being made because there's big companies with lots of money who are influencing that open source project because they want to make money off of those features. Test runners and internal tools just don't work that way. Most executives don't even have any idea that they exist, right? So, and then what I'm describing here is actually I'm claiming at least the state I'm describing here. This isn't really my opinion. This is what I've observed at various shops over the years. So the people who author test runners and who author these kind of tools, they know that we're doing this. Like they know that we've built all our little convenience methods on top of it that rely on the output being the way it is, and they tend to be conservative when they change it. If you look at the PHP unit runner output, for instance, it's looked the same since I started using PHP unit. I think it's probably true for JUnit, though I'm less familiar with that. But certainly the Ruby test runners I see today, the output looks almost exactly like the Ruby test runners that I saw when Rails first came out. Because there's no standard, there's no global body saying like, oh, you need to change it. It just basically, it is what it is and it stays that way. And it's perfectly acceptable on a mailing list for an internal tool for someone to write into the maintainer and say, hey, like I have tooling that relies on your output being the way it's always been. Like you can't do this patch that changes it. So for Nginx, that would be insane, right? Like, but this one company doesn't want to add, doesn't want any new feature to Nginx or Apache, and so we're going to hold the industry back. Like that's crazy, but because people are building custom tooling on top of these internal, tools, especially xUnit runners, it's pretty safe. And again, I mean, if it does change, it's exactly like dealing with a Selenium UI change. I mean, there's an object repository somewhere, either one you've made or more often in a test runner. I mean, all the messages are in one place generally, right? So, I mean, you can just take a look at what the message is now, and usually you can just look at the diff in GitHub if it comes up and say, okay, well the message used to be this and it's this, so I need to search and replace my code. It's as simple as that. But again, in practice, never.
Which is good, thank you.
Sure. Yep.
You provided us with the examples of gathering some metrics like code coverage and static code analysis with your test runners. Do you see there any pros with these test runners over some ready tools like Sonar static tool analysis and so on?
So that's a great question. It depends on what you want, right? So for just straight static analysis, yeah, a tool like Sonar can be great. I guess what I'd say is the graphs that I showed. So I was showing our graphs at Teachers Pay Teachers intentionally are really, really granular, much more granular than the kind of graphs you would get out of Sonar. So most tools, they'll give you test coverage on your suite, right? We don't want test coverage on the whole suite. right? We test a lot of stuff, but the only place that we really care about increasing test coverage on a regular basis is models, because that's where all the risk is. So there was some customization that needed to be done in order to get coverage for only that, only that one area. And it was actually easier to just do that with a command line tool, PHPMD, than to try and customize Sonar. But Sonar is a great tool for just getting 360-degree visibility into all of your code, definitely. Again, what I've found is that a lot of developers who are under deadline, under pressure, and not familiar with, static analysis is not something your average developer is familiar with in my experience. They'll go, a lot of developers are like, oh yeah, I remember doing that in school, and like, I wrote some kind of parser and like abstract syntax tree or something, but when you get into, granular static analysis, it takes some explaining. So I've had a hard time showing dev teams a tool like Sonar because they just get overwhelmed and they shut down. So that's why the customization. And then, if what you want is coverage related, like obviously you need to run the test runner, and then then the output's right there. So you might as well feed it directly to Graphite rather than feeding it up to some third party. That said, we do send all of our coverage. We use Code Climate, which is a hosted service similar to Sonar. And we send a lot of our coverage data to Code Climate, and that's directly received by the developers. So they get, Code Climate does a lot of prettification, like gives you a letter grade on your code, and it'll tell you if coverage went up or down for a particular commit, but that's a different use case. Yeah, sure. Oh, and I think we're out of time. Yep, done. Okay. So thanks a lot.